everyone, my name is Sindhu from 8576 Golden Warriors Robotics, and today we're going to go over the basics of FTC drivetrains, which are basically the most foundational part of the robot and how it moves across the field. In this video, we're going to explore the different designs, wheel types, and even the pros and cons of each system. So let's get started. So firstly, let's look at what is a drivetrain. A drivetrain is essentially the part of the robot that makes it move. So it's going to include your motors, your gears, belts, structural supports, wheels, and even the control hub. The drivetrain can be categorized based on many different factors, but most of the common ones are the wheel type, the base shape, the amount of rotation that's transferred, and the number of wheels. Okay, so first we're going to go over drivetrain shape. There are three main drivetrain shapes. Firstly, we're going to look at the square drivetrain shape. It's great for pushing and it's very robust. However, the problem is that it sacrifices the intake space. The U drivetrain leaves more room for intake, so it's comparatively better in that regard. However, it's less robust and it needs more support. So then we have the H drivetrain, and that allows for space on both sides. So that's good because there's a lot more space. However, it's not as strong and it's harder to push. There's also other experimental shapes such as the X and triangle. However, they usually take up a lot more space and they're very hard to program, so they're not recommended for beginners. Okay. So we're going to go over the wheel types. There are four main wheel types: Omni, Traction, Mecanum, and Trends. Firstly, the Omni wheels allow you to turn easily, but they don't really hold onto the ground that well, so they have very less traction. Traction wheels are better because they grip the floor really, really well. However, they're not able to turn as smoothly. The Mecanum wheels are the most popular to use in FTC because they have the small little rollers. It's the one at the very top, so it's able to move in any direction. And lastly, the Trends are great for climbing. However, they're very fragile and hard to turn, so they're not used frequently. Okay. So now we're going to look at the drivetrain types. There's the two-wheel, four-wheel, six-wheel, and eight-wheel, which basically tell you how many wheels each drivetrain has. So I think that part's really simple. However, there's also treads, mecanum, H drive, Z drive, and even more advanced swerve drives. Each one has their own trade-offs in manufacturing stability and complexity, and we're going to go over that in the next slides. Okay, so now we're going to look at our two-wheel drives. So in our two-wheel drives, they have four wheels. However, only the back two are powered. That means it's one of the more simple drivetrains since it only needs two motors, one motor for each wheel that's driving it. However, the downside is it's one of the slower types of drivetrains and it's the hardest to maneuver since you're going to only be able to maneuver the robot from its back. In the two-wheel, so the two-wheel is one of the most simple ones that you can make. So next one we're going to look at is the four-wheel drive. So in this one, there are still four wheels. However, they're all powered, so they all have four motors. This setup is often combined with traction and omni wheels for balance, and it's very stable on ground and it's pretty easy to build as well. However, it's important to note that it's a lot easier to tip compared to the six and the eight wheel drives, which allow for more stability. Okay, so now we're going to look at the six-wheel drive. The six-wheel drive is one of the most common ones that can be used in FTC. You can use omni wheels on the corners, and you can use lower and middle wheel if all the wheels are traction wheels. In a six-wheel drive, it provides a lot of strong traction for the robot, aids in stability, and has a great defensive ability. However, it's a little bit more challenging to construct as a whole. Okay. And next, lastly, for the amount of wheels is the eight wheel. The eight wheel build drives are the most complex. However, the upside is that they're the most stable. They add onto the six wheel design and they add another set of wheels in the middle. This allows it to increase its traction and stability. However, it'll take up more space and it's a lot harder to build compared to a two wheel or a four. Okay. So now we're going to look at our tread drives. So tread drives allow these robots to climb over obstacles more easily. However, they're very complex, fragile, and they're very bad at turning. That's why they're not seen often used in FTC. Okay, now we're going to look at the Mecanum drive train. And the Mecanum drivetrain is actually one of the most commonly used ones in FTC, and it's arguably one of the best. And that's because each wheel is able to move independently because of the rollers that allow it to move at a 45-degree angle. That makes the robot be able to move side to side, allowing it to be much more versatile than the other types of drivetrains. So now we're going to look at the X drive, H drive, and the Qs. So these systems also allow the robot to move in a sideways motion. The X drive uses wheels in a 45 degrees, and Kiwi uses three wheels at 60 degrees. And then finally, the H drive will add sideways wheels at a four-wheel base. While the X drive can be a lot faster than the Mecanum is usually a lot more favored because it's simpler and more reliable as a whole. Okay. Okay, so next we're going to look at the coaxial and differential swerve drives. So swerve drives are theoretically the best to provide the robot and its steering because it has a lot more maneuverability. However, like in practice, they're extremely difficult to design and code, and the FTC motor and swerver limits make them a lot more impractical to build. That's why the Mechanism remains like the go-to choice instead of these swerve drives, even though they're supposed to be better theoretically. Okay. So all in all, drivetrains are the backbone of FTC robots. If you don't have a drivetrain, you don't have a robot that you can use. And understanding which drivetrain benefits your team helps make or break your robot. You need to choose the right one depending on your game strategy, your resources, and your team building skills. While there's a lot of advanced options that exist, Mechanism and six-wheel drivetrains tend to be the most effective in these teams. I hope that this was helpful and thank you guys for listening.